So there are going to be times when it's going to give you a picture of a quadrilateral. It's going to have some things marked, or it's going to tell you what type of quadrilateral you have, and it's going to ask you to solve. And there are going to be other times when it gives you coordinates, and it's going to say what type of quadrilateral do you have. All right? And you cannot assume based on just what it looks like as to what it is. And so there are some cases that may happen when you have this. The ways that you can do this is you can check the congruency of the sides and the congruency of the diagonals. We're also going to talk about potentially using slope as well, because I'll take that as an option, but all of the examples that we do use just the length of them. So the first case is you could have a parallelogram. Opposite sides are congruent. So you'll see that you have these opposite sides congruent, so you automatically know you have a parallelogram. But then when you do it, diagonals are not congruent. Diagonals are not congruent. All right, there is another one that does not have congruent diagonals. Of these 4 that are listed right here, which also does not have congruent diagonals? The rhombus. But the difference here is that when you find the length of the 4 sides, for a rectangle, you will have these 2 congruent and those 2 congruent. For a rhombus, you would have all 4 congruent. So you would have 4 congruent sides, but the diagonals are not congruent. That's a rhombus. Opposite sides congruent, and the diagonals are not congruent. That would be a parallelogram. And then you have your rectangle and your square. For a rectangle, you have congruent opposite sides and congruent diagonals. For a square, you have congruent all 4 sides and congruent diagonals, okay? And so you can take just the coordinates and figure out what do I have as far as what type of quadrilateral I have. And so we're going to do that using some formulas here. Now I've listed 2 formulas. The one that these examples use all the time is distance. I want to point out slope as well. All right, because there's another way to use this using slope and not having to use your distance quite as often. So your distance formula, if you'll recall, is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. You will need to have that memorized. That's going to be used over and over. And then your slope is y2 minus y1 over x2 minus x1. So if I'm trying to show that sides are congruent, I can do the distance formula. And if I get the same number, the sides are congruent. They're the same distance, right? And so this shows me that my lengths are the same. Now, it does not mention in these examples slope, but another thing you can also use is if you have right angles. How would slope help me to know whether or not I had right angles? Do y'all remember anything about slope and lines that we've done? So parallel lines have what type of slope? Do y'all remember? If lines are parallel, what do we know about their slopes? Back from our memory. They have the same slope. Remember, we have done graphs of lines, right? And so if you have a line like y equals 3x plus 2 and y equals 3x minus 1, those are going to be parallel lines. And so another way to tell if you have parallel lines, at least, is if they have the same slope. So you could potentially take 2 of your opposite lines and see you had parallel lines. All right? And then we did also perpendicular lines. So if I had y equals 3x plus 2, perpendicular would be y equals negative 1/3 x. Something like that. Remember negative reciprocals. Perpendicular lines tell me that I have right angles. And so there are cases where one way to prove it is not only to use maybe the diagonals, but also to use the slopes to see if you had parallel or perpendicular lines. Because if you have one set of perpendicular lines in a quadrilateral, all 4 of them are, because that's one right angle means all 4 are right angles. And so you can use both of these to do this. I will say all of these examples use the distance formula. So if you prefer to use just the distance formula, you may. But you can also prove that you have right angles and that you have parallel lines as well using slope. So let's look at this first example, this first page. They gave us the vertices. They want us to determine the quadrilateral's most specific classification. And then they gave us A, B, C, and D, 4 different points. I will say sometimes, even if you don't do it perfectly, it sometimes helps you to sketch it, all right? So if I were to look at 9, -4, that would take me right and down. And so you can say, okay, A is down here. 8, -2, well, that would take me right and then down not as far. 2, -5, that would take me +2, so not as far right, but down a little bit farther. And then 3, -7, that would take me here and maybe a little bit further down. Like, I don't have to do it exactly. Obviously, if I were to put this on coordinates, I would want them perfect. But it gives me an idea of which ones I'm trying to find. Does that make sense? And so even if you don't do it perfectly, you can say, okay, I went really far right and down 4. I went a little less far and down 2. I went close and down 5, a little further and down 7. And so it gives me an idea of where A, B, and C are logically on a coordinate plane, because I'm about to use the distance formula. So you want to have an idea of what are sides and what are diagonals when I start doing this, all right? For the first thing it does is it does all the sides first, all right? So it does all the sides. So they do A to B first. So we're going to do the sides, A to B, B to C, C to D, and then A to D. And we're going to see how long each side is. And we're going to implement our formula for this. So we're going to say, well, my formula is going to be the square root. I'm going to subtract my x's and square them, subtract my y's and square them. So from A to B, I would say 9 - 8 squared, and then -4 minus a -2 squared. And so I get 9 - 8, that's 1. 1 squared is 1. -4 minus a -2, that's just -2 squared is 4. So this is going to be the square root of 5. And you can leave it. You don't even have to simplify these. Even if I could simplify, you can just leave it. It's perfectly fine. And we're going to do that all the way across. So we're going to do that for all of these. B to C. We're going to get this. And then C to D. We're going to do this 4 different times. So you will know your distance formula before this is all over. And then A to D. So this tells me a couple things. This tells me that AB and CD are congruent, and this tells me that BC and AD are congruent, right? So I know I have bare minimum what? I know I have a parallelogram, right? It's because I know I have opposite sides that are congruent. I also know that I do not have a rhombus or a square. Why do I know I don't have a rhombus or a square? Why do I know that? What would be true of a rhombus and a square? All 4 of them would have been the same exact length if this had been a rhombus or a square, right? So I have eliminated rhombus and square. I've narrowed it down to either parallelogram or rectangle, okay? The difference between a parallelogram and a rectangle are the length of the diagonals or the slopes, right? So if I have diagonals that are congruent, then I would have a rectangle. If I have diagonals that are not congruent, I would just have a parallelogram. All right, so if I use distance formula yet again, I would do the distance formula for my diagonals. A to C, B to D. If those are congruent, I have a rectangle. If they're not congruent, I stick with a parallelogram. The other thing I could potentially use is the slope formula. All right, if I compare this slope to that slope, perpendicular, negative reciprocals would mean I have a rectangle. Anything else would mean I just have a parallelogram. And so at this point, you can do 2 different things. In this particular handout, they always use distance formula. So for this one, they're going to do A to C, they're going to do that diagonal, and they're going to do B to D, this diagonal. All right? And so when you do A to C, you're going to do that once again. You're going to say A to C. And you're going to get 9 minus 2, so you're going to get 49. And 1 squared of 50. And then you'll do B to D. So we're going to do these. So we'll say 8 minus 3, negative 2 minus a negative 7. So you're going to get 5 and 5 actually. They are the same. So what type of figure do I have? I have a rectangle. And so now that I have proven that I have opposite sides congruent and diagonals congruent, I know that I have a rectangle. So the most specific definition for this one would be a rectangle. Most specific description, rather, of this would be a rectangle. If those had not been congruent, I would have said parallelogram. Question. So if we look at this example here, at this point, we know that we have either a parallelogram or a rectangle. And so what I could have done is I could have taken the slope of AB. So if you remember, the slope of AB is going to be y2. So if I'm doing the slope here, I'm going to say y2 minus y1 over x2 minus x1. And so I get negative 2 plus 4 over negative 1. I get a slope of negative 2. And that is my slope here of AB. All right? And then I can take the slope of C to B. And so if I take the slope of C to B, then I would say y2 minus y1. I do this right, hopefully. So B to C, I would say y2 minus y1 over x2 minus x1. And so I would get negative 5 minus a negative 2, which is negative 3. And 2 minus 8, which is negative 6. That would give me positive 1/2. And so by instead of doing this here to talk about the diagonals, I could have done this piece to look at the slopes. And I would see that this slope is negative 2 and this slope is positive 1/2, which are negative reciprocals of each other, which would have told me this is a right angle. And then I could go straight to a rectangle instead of doing the distance formula 2 more times, okay? So I want to use this example and the one prior with the slope formula and show you what also could happen with the slope formula. That same method here, instead of doing the distance formula, again, I've already proven 4 congruent sides, all right? 4 congruent sides. I could have taken my slope formulas. And if I had done the slope formula, let's say for Q to R, if I have negative 7 minus a negative 5, negative 2 minus 1, I would get negative 2 over negative 3, 2/3. And then the slope of R to S, I could say negative 5 minus a negative 7, 1 minus 4. Over negative 3. Those are not the same. They're not negative reciprocals of each other. So this automatically tells me I don't have a right angle. So I have 4 congruent sides but no right angle. That leads me to rhombus. So there are two ways to do these. You can do your distance formula always. And if you're comfortable with the distance formula and you're like, I know what I'm doing here, I'm going to do distance formula, that's fine. Or if you're like, no, I want to do slope and see what I have, you can do that as well, as long as you have proven that you have what you tell me you have, okay? So what I mean by that is you can't stop here and say, oh, I have a rhombus. Because I could say, no, you could also have a square. Prove to me you don't have a square instead. Does that make sense? So you have to do enough to show me that you specifically have exactly what you've told me. And I can't come back and say, no, this could also be this. You didn't prove it's not this, okay? And so with these, you can do it multiple ways, but you need to be able to show that what you have given me, without a doubt, gives me one and only one option here, not other options. So like if you just said, hey, the diagonals are congruent, I would say that's multiple things that could have congruent diagonals. You have to do another step. But what that other step is could be something other than what this is telling you on this particular sheet.